All right, we're going to crack open a hidden puzzle that, believe it or not, quietly powers our entire high-tech world. It's a story about making things faster, smarter, and solving a very, very expensive problem with a brilliant new idea.
So let me ask you a question. What could your smartphone possibly have in common with a little custom t-shirt shop? I know it sounds a little random, but stick with me, because the answer reveals one of the biggest secrets behind all of modern manufacturing.
To get to that answer, we've got to start by stepping inside the super high-stakes world of semiconductor manufacturing. Yeah, we're talking about the places that build the literal brains of our digital lives. You see, making a single computer chip, it's not simple. It's this incredibly complex dance with hundreds of different steps inside these massive, multi-billion-dollar factories they call fabs. And in a place like that, every single second of wasted time can mean millions of dollars down the drain. So efficiency isn't just a nice-to-have, it's absolutely everything. And the main villain in this whole story, the real efficiency killer, is something called setup time. This is all the dead time, when a machine has to be reconfigured to do a different job. You know, like swapping out a specialized gas for one process or changing a super delicate photo mask for another. All that downtime is just a massive production bottleneck.
Okay, I know that all sounds pretty technical, so let's make this crystal clear. We're going to use a simple analogy. Let's pretend we're running a t-shirt shop.
And business is good. We've got orders flying in for all kinds of different designs and in colors. And just like that giant chip factory, our #1 goal is to be as fast and efficient as we can possibly be. We got to get those shirts out the door.
Now, in the factory world, they have a term called a job family. It's just a group of jobs that all need the exact same machine setup. In our t-shirt shop, that's super simple. It's all the orders that need the same color ink. So, all the red shirts are one family, all the blue shirts are another. You get it?
And common sense, right, tells you that changing the ink color is a real pain. It's messy, it's slow, you got to clean the whole machine. So, to be efficient, we use this strategy called serial batching. Basically, we print all the red shirts at once, then we print all the blue shirts, and so on. We group the same jobs together to avoid those annoying setup times.
But here's the twist. Here's what makes this a genuine puzzle. Management comes in with a hard rule, a minimum batch size. They tell us, look, it's not worth the time and money to set up the red ink unless you have at least 10 red shirts ready to print. And that one little rule, it makes scheduling everything a massive headache. So let's just recap the puzzle here. We get a flood of different orders. We have to group them by ink color, then schedule those groups to cut down on how many times we have to clean the machine, and we have to make sure every single batch we run is big enough to meet that minimum size rule. Believe it or not, this is the exact same puzzle those multi-billion-dollar factories are trying to solve every single day.
People have been trying to solve this problem for years, but the old way of doing it was, well, let's just say it was a bit clumsy.
The old method was kind of like trying to run our t-shirt shop by first creating this gigantic binder. And inside this binder, you've written down every single possible valid batch you could ever create. You know, a batch of 10 red shirts, a batch of 11, a batch of 12, a batch of 10 blue shirts. You see where I'm going? It's a huge brute force approach.
And this is where you can really see the difference. The old way has to pre-calculate everything, but it runs into this problem they call the curse of dimensionality. The more jobs and colors you add, that binder just grows exponentially until it's impossibly huge and slow. The new way is totally different. It doesn't need the binder. It just looks at the actual jobs you have and reasons from there. It's compact, it's intuitive, and it's way, way faster.
So what is this new way? What's the secret sauce? Well, it's all based on this one surprisingly clever and really elegant trick that just changes the entire game.
This new method is called the aligned model, and the first thing it does is just toss that giant binder in the trash. It doesn't need a pre-made list of every possible batch. Instead, it looks at the real-time sequence of jobs and cleverly groups them together into what the researchers call family blocks.
Let's see what that looks like. Here's a terrible schedule for our t-shirt shop, right? We print a red shirt, then we stop, clean the machine, print a blue one. Then we stop, clean it again, just to print another red one. We've got 2 red shirt orders, but they're broken up by a costly setup. Super inefficient.
What we want, obviously, is a schedule that looks like this. We group those 2 red shirt jobs right next to each other. We create one family block for the color red, and bam, we just saved ourselves an entire machine cleaning cycle. This is exactly what the new model figures out how to do, automatically.
Okay, so here is the clever trick. For every single job in a group, like our two red shirts. The model creates a kind of virtual time slot, or a label, that covers the entire group. So both red shirts get a label that basically says, I'm part of this red group from start to finish. Then, the model can just count how many of those red group labels are active at the same time, and it instantly knows the size of the batch. It's a brilliantly simple way to check that minimum size rule without needing that giant binder of possibilities.
Okay, this alignment trick, it sounds elegant, it sounds smart, but does it actually work when things get messy and complicated? Well, the researchers put it to the test, and honestly, the results are stunning.
Get ready for this. This is the big number. When they tested this on massive, complex problems, we're talking up to 500 different jobs, just like in a real chip factory, the new Align model found schedules that were up to 25% better than anything that came before it. A 25% improvement in this industry, that is absolutely monumental.
This chart really says it all. The new model, that higher bar, just consistently finds better answers. But what's maybe even more impressive is the speed. It finds these way better schedules in just 10 to 20 minutes. The older methods could take hours, sometimes even days, to find a solution that wasn't even as good.
So, okay, we've solved a really tough puzzle for factories, but why should this matter to the rest of us? You know, people who don't work on a factory floor.
Well, because smarter scheduling is so much more than just an academic exercise. It means factories are more efficient, which leads to lower costs for the things we buy. It helps create supply chains that are less likely to break. And maybe most importantly, by clearing out these bottlenecks, it actually speeds up the pace of innovation. It means we get the technology of the future into our hands faster.
And that kind of leaves us with one last big question to think about. This was all about finding a really elegant, simple solution to a super messy problem, just by thinking about it in a completely new way. So if one smart algorithm can do all this for computer chips, what other huge global bottlenecks, in things like logistics or healthcare or energy, are just sitting there waiting for their own clever alignment trick to be discovered? Something to think about. Thanks for joining me.